Yo, what is up YouTube? Today I'm really excited to share with you a new video series that I've been working on for quite a while now, where I'm going to be showing you from start to finish how to build a really pretty, really robust multi-sig wallet application that runs entirely on the Ethereum blockchain. So if that sounds really cool to you, then good, because we're going to have so much fun coding this out, and all of you are going to learn an absolute ton about Web3 development. So for those of you who don't know, my name is Evan McGrain, and welcome to Love the Blocks, where I teach you blockchain development. So if that's something that you're interested in, then I'd really appreciate if you could just take the time to quickly like this video, subscribe, and hit the bell button, because it really helps this channel out with the YouTube algorithm. So before we actually get into coding this multi-sig wallet out, I just want to go over the main layout of the application, and also just to go over some of the dependencies and frameworks that you guys are going to have to install in your machine in order to be able to follow along with this video series. So the main wallet application that we're going to be building is going to be split up into a variety of different sections. So when a user first logs on, they're going to be faced with a login page that's going to allow them to create unique accounts and log into the application itself. So we're going to be creating a one-click MetaMask login system with the help of a Web3 framework specifically tailored to Web3 applications called Morales. And Morales offers a really easy to implement MetaMask one-click login system that we're going to be using in this application. So once a user actually logs in with their account, they're going to be faced with a new page that shows them a list of all of the current available wallets that they have, and they're also going to have the option to click a button to create a new wallet. So this wallet is really flexible because users aren't just restricted to having one wallet. Just like MetaMask, they can choose to create as many different wallets as they want. So once the user logs in and chooses the wallet they want to open up, then they'll be faced with the main application itself. And the main application is actually going to be split into a variety of different sections. For example, we have an admin section, we have an account section, and we have a transfers section. So once the user logs in, they can navigate to the admin section, and here they can choose to dynamically add and remove wallet owners from the wallet. And this is really cool because it's really flexible in such a way where that we actually don't hard code a predefined set of wallet owners before we actually launch the application onto the Ethereum blockchain. So yeah, once the user logs in and they choose all of the wallet owners that they wish to add, then they can navigate to the account section, and it is in this account section where the user can choose to deposit and withdraw Ethereum into their wallets. We're also going to be using what's called the OpenZeppelin smart contract library in Solidity in order to integrate ERC20 tokens into our wallet. So the user is going to have the ability to not only deposit and withdraw Ethereum, but they'll also be able to deposit, withdraw, and transact in ERC20 tokens as well. So once the user deposits funds into their wallet, they can now navigate to the transfer section, where here all of the main logic that we're going to be spending a lot of the time coding out takes place. So when a user navigates to the transfer section, they can initialize a transfer to transfer funds from the wallet to another address or account. However, since this is a multi-sig wallet application, whenever a user initializes a transfer, the funds will not get sent out immediately. Instead, other wallet owners are going to have to log in and approve the transaction so that it can actually get executed. And I've also implemented a cancellation ability, whereby if a user creates a transaction and then they change their mind, or perhaps they click the transfer button by accident, then the user will indeed be able to cancel any transfers that they've created, as long as the transfer doesn't have the required amount of approvals it needs in order to get executed. So in general, that is the majority of the features that this wallet application is capable of, and as you can see, it's really pretty, and it is capable of executing some complex functionality. So yeah, I hope all of that looked really amazing to you, and that's what we're going to be building. So just before we actually start coding the smart contract out in Solidity, I just want to go over some of the dependencies that you're going to need in order to follow along. So I'm just going to switch my screen here, and the first dependency that we're going to need is called Node.js, and you can download Node.js from nodejs.org, and pretty much Node.js is a JavaScript backend backend runtime environment that's mainly used for different backend operations. However, Node.js can also be used in combination with other front-end frameworks like React.js or Angular in order to develop client-side applications. So we're actually not going to be using Node.js for backend operations, but we're going to be using Node.js to access the Node package manager, which will allow us to install a lot of different packages into our projects just to make coding more efficient and quicker. So yeah, once you downloaded Node.js, you can click this current version. It's probably I would recommend installing the current version. Once you download Node.js, you can open up a terminal here. Sorry, I was just practicing off screen to make sure. And in order to know if you've installed Node.js correctly, you can just type node-v into your terminal. And if you get a response that displays the version of Node that you have, then you know that you successfully installed it on your machine. However, since I already have it installed, I'm not going to go through the installation process, so I'll leave a link to a video before in case you're having any issues. So the next thing that I'm going to ask you to download, although it's not required, is the Visual Studio Code IDE. And the reason I think you should install this is just because it makes coding really, really fun, because the Visual Studio Code editor or IDE comes with a load of different extensions that you can download in terms of syntax highlighting and auto code completion that just makes coding in Visual Studio Code an absolute joy. So you can get Visual Studio Code by going to code.visualstudiocode.com and just downloading the latest version here by clicking this download button. So the next thing that is required for you to install is MetaMask, and MetaMask is just a crypto wallet that gets installed as a browser extension on your current browser. So you can get MetaMask from going to metamask.io, and you'll be taken to this page here. You can just click download. MetaMask is actually only a browser extension, so it actually is not a piece of software that gets installed on your machine. But just beware, if you're using another browser such as Microsoft Edge, then you will not be able to download MetaMask because it's not compatible. So I just recommend using Google Chrome because that's what MetaMask is well, more tailored for than anything else. So the next big piece of software that we're going to need is called Truffle. And Truffle comes as a variety of different packages in what's called the Truffle suite. And you can download Truffle onto your machine by going to truffle.com/truffle. And you'll notice here that we don't actually download Truffle, but rather we install it as a package by using Node.js. So now you can see why we need Node.js, so that we can install some of these packages that we need to install in order to code out this application. So Truffle comes with the Solidity Smart Contract Programming Language. It comes with Python, Web3.js, and a variety of other things such as a testing framework and the ability to deploy our smart contracts to the Ethereum blockchain. So to install Truffle, you can just come over here and copy this command. Again, you can open up your terminal and just paste in the command and hit enter to run it. And the installation process might take around, anywhere from 5 to 10 minutes. And obviously, I'm not going to install it because I already have it installed, but when the installation process finishes, you can check to see that you installed it correctly by typing truffle version, with 2 F's, so truffle version. And if you run this command and you get an output similar to this, where it gives the Truffle version, the Solidity version, the Node version, and Web3 version, then you know that you've installed Truffle correctly. So the last thing that we're going to need is called Ganache. And Ganache is also bundled with the Truffle suite, but we need to actually download it as a piece of software on our machine. So you can get Ganache by going to trufflesuite.com/Ganache and just click this Windows download button, or Mac if you're operating on a Mac. And Ganache is pretty much just a local blockchain that gets run directly on our machine. And what we use Ganache for is simply testing our Web3 applications. So Ganache is a blockchain that comes with, I think, 10 or 15 predefined accounts that are all deposited with 100 fake ether. And we can use these different accounts to simulate being users using our application. And the great thing about Ganache is there's no monetary risk. And since we're the only person that's actually using the Ganache blockchain, then you'll never have a backlog of transactions that are waiting to get mined. So in other words, all transactions get executed immediately. Whereas if we were to deploy our application straight away onto the Ethereum mainnet or testnet, then we would not be able to execute our transactions immediately. They would, there'd be a bit of time in between us calling the function and it actually getting executed because of this backlog of transactions that are waiting to get mined. So if you're new and you don't understand blockchain development and that sounds confusing to you, then don't worry. I'm going to explain all of these different frameworks and what they do in great detail whenever we actually get to using them for the first time. So that is everything that you're going to need in order to follow along with this video series. And now we can actually get into developing the smart contract code. So I'm not going to open up Visual Studio Code right away. Instead, we're going to start developing the multi-sig smart contract using what's called Remix. And Remix is just pretty much an online development environment or online IDE specifically for developing smart contracts. So we can get to Remix by going to Remix, just typing in Remix IDE into Google or whatever browser you're using. And the first option will generally be the one. So it's remix.ethereum.org. And Remix is really good because it's very user interactive, and its main selling point is that it makes developing smart contracts in their early phase much more quicker and much more intuitively than it would be if we were to use VS Code from the start. And you'll see what I mean by this when we actually eventually take our code into VS Code. So when you're taken to Remix, you'll be faced with this page here. And in order to create a contract, you can just click on this little document icon here and type in the name that you want to call your contract. So I'm going to call it Multisig .sol, and .sol is what you type in order to initialize a Solidity smart contract file. And then you'll be taken to this text editor here where we can write all the logic and code that defines our smart contract. So in order to actually create a contract, there's two things that we need to do before we can start writing any logic. And that is, we need to specify what version of Solidity that we're using. And we can do that by typing pragma and then Solidity. Oh, sorry, I spelt it wrong. Solidity. And then here we want to specify the version of Solidity that we want to use. So I'm going to use 0.8.7. Not 8, 0.8.7. And just one thing that you should note is that the version of Solidity that you specify here must be the same as the version of Solidity, but you can just get to that by clicking this second icon here. So the version of Solidity that we specify must be the same as what's selected in the current compiler on Remix. So you can choose any different version of Solidity that you want, but for now I'm just going to stick with the 0.8.7, which is the current local build. And then the second thing that we need to do before we can start writing our contract is we actually need to declare a contract itself. So to do that, we can type contract, and then we can give it a name. So I'm going to call it Multisig. And then we just open it up with curly braces, and in here we can start to define all of the logic of our wallet. So the first thing that we need to do is we need to figure out a way to add users or add wallet owners into our wallet. And the way that we're going to handle this is we're going to create a dynamic system where we can add and remove users by will into the wallet. But in order to do that, we need to specify the first user. And the first user is going to be the person who initially launches, deploys, or creates the wallet. So to do that, what we're going to do is I'm going to set up a global variable called main owner. And in order to create a variable in Solidity, we need to typecast it. So since an owner is an address or an account, we need to typecast it by typing address. And then we can just give it a name called main owner. And we're not going to actually to initialize it on the declaration. So what we're going to do is we're going to use what's called a constructor to assign this main owner variable to a value. And if you're familiar with languages like C or C++, you'll know that a constructor is used to execute a body of logic or code that gets executed whenever the script or contract in this case is deployed for the first time. So to declare a constructor, we can just type constructor. And we can pass in arguments here, which I'm not actually going to do. And here, by opening up with curly braces, we can define all of the logic that we want to get executed by the constructor. So what we're going to do is we're going to take the account or the address of the person who launches this smart contract, and we're going to take that account and set it equal to this main owner variable here. So to do that, what we can do is we can just simply type main owner equals message.sender. And message.sender is just simply a keyword variable in Solidity that maps or assigns the value of the person who's calling the function to this message.sender variable. So if you're unfamiliar with Solidity, pretty much what this means is if I have a function, say called function1, and I execute or call that function as address1, then this message.sender variable will store address1. Whereas if I have the same function and I call it as address2, then this message.sender variable will store address2. So I'll just show you what I mean by this in a second, but now that we have this main owner variable storing message.sender, what we can do is we can define an empty array that's going to store all of the wallet owners at any given time, and we can append this main owner into that array. So in order to do that, we need to make an array itself, and it's going to be an array of addresses. So we're going to typecast this array as an array of addresses, and to just tell Solidity that it's an array that we're dealing with, we use these square brackets. And then I'm just going to call this wallet owners. And again, we're not going to initialize it on creation. What we're going to do instead is initialize this wallet owners array in the constructor by saying wallet owners dot push, wallet owners dot push, and we're going to push in this main owner that we defined. So now that we have done this, when our contract gets created, it's going to take the address of the person who deployed the contract and push it into this wallet owners array. So to see that in effect, we're going to make a function, and to declare a function in Solidity, we can just type function, give it a name, and we're going to say get wallet owners. And we're not going to pass anything into this function. And in Solidity, there's different visibility levels that your function can have. So there's public, private, internal, and external. And just quickly to go over them, a public function means that anyone can execute it from anywhere, okay? And a private function means that no one can execute your function. The only way that it can get executed or called is if another function in your smart contract actually calls it. And we'll see what we mean by this in later on as we develop this contract. An internal function means that it can only get called in the contract itself or any inheriting contracts that we have. And lastly, an external function means that the function should only get called from external contracts that are not linked to this contract or the contract in any way. So we're going to have this function's visibility as public, so anyone can call it. And what we're going to do is we need to restrict it to this view, or we need to include this view restriction on our function here, and the reason that we do this is because this get wallet owners function is a read-only function. We're only querying the blockchain for data. We're not writing data to the blockchain. So whenever you have a function that's only querying the blockchain, or in other words, whenever you have a function that's only viewing the blockchain data, then you need to restrict it to view. And then we're simply going to return we're going to simply return an array of addresses, which is going to be our wallet owners array. And we also need to write some memory here. We need to allocate some memory to this. And then we're just going to open it up and return our wallet owners array. So this memory allocation of memory might seem confusing to you, but the more we code, the more clear this will come. So if we save this now, you see that we get no errors, and if we come to this third tab here, you'll see that we have the option to deploy the contract. So before we do, in this deployment tab here, we have a variety of different things that we can choose. So we can choose the runtime environment that we want to use. So it's set to default as the JavaScript virtual machine, but we also have these options here like injected web3 and web3 provider. So injected web3, for example, just means that we can launch or deploy our smart smart contract to testnet or mainnet using Remix. So you don't have to worry about any of these here. We're not going to be using them in this series, so just stick with the default JavaScript runtime virtual machine. The next tab here just shows a load of different accounts that we can use to simulate being different users using our contract, and they're all credited with 100 fake ether. This gas limit, you can just ignore it. It just specifies the gas limit of the contract. And this value tab here, we just use this if we want to, you know, send someone ether or deposit ether into our smart contract. We can specify how much we want to send in here, and then we can just choose different denominations of ether, such as Wei, Gigaway, Finny, and so on. So, for example, a Wei is just 10 to the power of minus 18th of 1 ether. So we can choose to deploy our contract here. And when we do, you'll see that we get an instance of the smart contract down at the bottom of the screen. And you can see that we have access to call this wallet owners function. And if we call it, you'll see that the wallet owners array consists of one owner, and it is of an address 0x5b. And you might be wondering, well, where did that address come from? Well, if we go up to this accounts here, we can see that we're currently using this contract as 0x5b. So now hopefully you can see what's happening here. We are deploying this contract as this account 0x5b here. The constructor is getting executed, and it's taking this account 0x5b and assigning it to the main owner variable that we initialized globally up here. And then it's taking this main owner and it's pushing it into the wallet array or wallet owners array, which we also defined globally. So that's what the constructor is doing. It's taking the account of the person who deployed the smart contract and setting that account as the initial owner of the wallet. So yeah, I hope that makes more sense now. Now that we've done this, we also want to create a system that gives this initial owner the ability to dynamically add new owners and remove other owners that are currently in the wallet. So to do that, we're going to create a function called add wallet owner. And here we need to pass in an argument or the address of the owner that we want to add. So we're going to pass in an address owner. And we're also going to have this function as public, and we're not returning anything, so we can just open it up and start writing the logic straight away. And just like we pushed in the main owner here, we're going to push in likewise the owner that we want to add. So we'll say wallet owners dot push, and we're going to push in the owner that we pass in as an argument. And boom, it's as simple as that to add a wallet owner. So we can now save this. And we can go to the deployment tabs. We'll delete this instance anymore because we don't need it. And we can deploy a new instance of the smart contract. And now you'll see that we have the ability to call this add wallet owners function or add wallet owner function. So I'm going to do that, and I'm going to get this second account here. I'm going to copy it, and I'm going to go back to this main account, and we can paste in this new owner. And we can add them, and you can see in this terminal down here that the transaction was successful. So if we get the wallet owners, we now have two owners. We have this first one, and we have the second one, which we just added. But there's a problem. So it makes sense for us to only be able to add wallet owners if the owner is being added by an already existing wallet owner. So you'll notice here that if I switch to this account 0xa, if I switch to this account 0xb or 0xc, then this account is not a wallet owner. It has nothing to do with our wallet. However, we can use this account to add an owner. So you can see that transaction went through. So this is a big security feature or a big security risk in our contract, because we have the ability to add owners as non-wallet owners. And you'll also notice here what I did was I added in the same owner twice. So now their wallet owners array consists of this account 0x5b, but there also is two instances of the account 0xa. So we want to eliminate that because you should only be able to add unique owners. So there are two security features that we need to cater for. So we can handle them in this wallet owners function by using what's called require and revert. So require is a built-in function in Solidity that pretty much allows us to impose or check that certain conditions are true before we actually execute the logic of a function. Yo guys, sorry for that cut just now. I just finished recording this video and I noticed that after I'd coded this function, my little webcam there in the corner had frozen, so I have to cut it out for you guys again. But yeah, we just left off where we had coded this wallet owners function out, and we had realized that we had two security risks. The first is that we were able to add duplicate owners, and the second is that we were able to add owners as non-wallet owners. So we need to handle both of these two security risks, and the first that we're going to do is the duplicate owner issue. So in order to make sure that we don't have any duplicate owners, what we need to do is we need to loop through our entire array, and we need to check that the owner we're passing in is not already an existing owner in the array. So that will handle the duplicate owner issue. So to do that, we can write a for loop, and in Solidity to write a for loop, you type for, and in the curly braces here, you specify the range you want to loop over. And we're going to say for uint I equals 0. And remember, we have to typecast our integers, and integers in Solidity are typed as uint, so that's just where that's coming from. So we want to say for I equals 0, I is less than wallet owners dot length. And then we want to increment a looping variable, so I++. And then we want to say if wallet owners of I is equal to the owner that we're passing in, then what we want to do is we know we've found a duplicate owner if this is the case. So we just want to call the Solidity's built-in revert function, which will revert the entire transaction as if it had never been called in the first place. And we'll just add a little message saying cannot add duplicate owners. So what this does is it loops through the entire array, and it checks each element to see if it's equal to the owner we're passing in. And if for any of our owners this condition is true, then we know we found a duplicate owner, so we revert with this revert built-in function. So that's the duplicate owners. The next thing that we need to do is we need to handle the situation where we don't want non-wallet owners to be able to add new owners. So to do this, we're going to have to loop through the entire array again, and we are going to want to make sure that the person who's calling the function, aka message.sender, we're going to want to make sure that message.sender is already a member of the wallet owners array. So to do this, I'm actually going to start out by setting a Boolean variable called isOwner. And we're going to set it initially to being false. And then we're just going to loop through. Oh, I'm out of indent here. Actually, it's this that's out of indent. Sorry there. I want to fix my indents. Here we go. So what we're going to do is we're going to loop through the entire array again. We're going to say for uint I equals 0. And then we're going to say I is less than wallet owners dot length, and incremental looping variable as always. And here we're going to use the same if statement. So if wallet owners of I is equal to message.sender, then we know that the person who's calling the function is already a wallet owner, and we're going to set isOwner equal to true. Then what I'm going to do is once we've found the owner, we're going to break out of this for loop, because once we found the owner, there's no need for us to keep checking. So we'll break out of the loop, and then we're just simply going to say require, which is another built-in Solidity function. We're going to say require that isOwner equals true. True. And then we're going to just add a little message that gets printed to the console that says only wallet owners can call this function, like so. And boom, that is the entire add wallet owner function. And I'm just going to save this now. Oh, I have a little mistake here. Spelled true wrong. And boom, so we can now test this. So let's deploy one more time. And let's see, firstly, can we add duplicate owners? So I'm just going to copy this address here. And notice that this is the address that's already the initial owner. So let's paste him in and try and add the owner. And boom, this reversion statement got executed, which, canceled the entire transaction. And we know that because we say cannot add duplicate owners. So now let's get this account here, which we know is not already an owner. Go back to our initial owner and paste it in. And boom, he successfully got added. So if we print out or call the get wallet owners function, you can see we have 0x5b and we have 0xa as owners. So now let's get a new account, this third one here, copy it and go to one of these accounts down here that we know is not an owner. And let's come in here and paste in that account. And if we add it, then we'll go boom, only the wallet owners can call this function. So now we've successfully handled those two security features, and our add wallet owner function is perfectly secure. So now that we've done that, we need to make the remove wallet owners function. So to do that, we're going to come down here and make a function called remove wallet owner. And here we're going to pass in an address owner. And what we're going to say is we're going to call this public. And in this code, we need to figure out a way to remove wallet owners. And we're actually going to use this logic here again, because we want to only make sure that existing owners can call the function. So we're going to copy all of this and we're going to paste it down here. And now you're going to notice something. If you want to be an efficient coder, you should always be looking at for ways to minimize duplicate code. And we have this exact same code up here in this add wallet owner function. So how can we get rid of that? Well, we can use what's called a modifier. And a modifier is a tool specifically tailored for helping us get rid of duplicate code in our functions. So what we're going to do is we're going to come up here and we're going to call or declare a modifier by using the modifier keyword. And we're going to call this only owners. And then we're just going to open it up here, and in here I'm going to copy this code, so we'll delete it, and I'm going to paste it into the body of the modifier like so. And what the modifier does is it's specifically used for when we're trying to do security checks on our functions. So this only owners modifier, we're going to use this on all of our functions, because for deposit, withdraw, create, transfer, we only want these functions to be able to be executed by wallet owners. So what we need to do is, the only thing we need to do in the modifier now is use this underscore button. And then what we do, sorry, I just want to get rid of this extra space here. And then what we do is we come down to our add wallet owner function, and if we want to restrict this function to the only owner modifier, we need to just type only owners, like so. So if we come down here now and call the add wallet owner for a function, for example, what it will do is it will come here and it'll go, okay, this function is restricted to only owners. So before it enters the body of the function, it will come up here and it will run this piece of logic. And if the logic checks out, then what it will do is this underscore pretty much means, okay, so this logic here checks out, okay, do the actual body of the add wallet owner function. And that's pretty much how we can use only owners or modifiers. So I'm just going to delete all of this because we don't need it anymore. And I forgot to put it in here, so we need that require statement here. So again, we call this function, it sees that it's only owners, it comes up here, it does all of this logic. If this logic checks out, then boom, it goes and it actually enters the add wallet owner function. So now that we've done that, I also want to restrict this remove wallet owners function to only owners, and now we can start defining out the logic. However, there's one bit of logic that we need to make sure of. And we need to make sure that the owner we're trying to remove is actually already an existing owner. So for this, what I'm going to do is I'm going to set a Boolean variable called has been found. Called has been found. And I'm going to set this to false initially. And then what I'm going to do is I'm also going to set a uint owner index variable, and we're going to set this equal to actually we'll leave it undefined at the moment, and then we're going to loop through the entire array again. So for uint I equals 0, I is less than wallet owners dot length, and then increment the looping variable, so I++, and we're going to say if wallet owners of I, sorry guys, my phone rang there, but so yeah, we're going to say if wallet owners of I is equal to owner, or the owner that we're trying to remove, then we know that the owner we're trying to delete is already an existing owner, so we can say has been found equals true. And what we also want to do is, now that we've found the owner that we want to delete, we want to also figure out at what index he's at. So I'm going to say owner index is equal to I, and then what I'm going to do is I'm going to break, because once we found the owner, then we don't want to keep doing extra computations. However, if the owner that we're trying to delete is not equal to the current index, we want to increment this owner index variable like so. And actually we don't need to, because we're assigning it to the I value here. So sorry about that. Right, so that is the first bit of logic that we need to do. And then we just need to require that this has been found variable is equal to true. And then we can say wallet owner not detected, like so. And now that we've satisfied both of these conditions, the only owners modifier and that the owner that we're trying to delete exists, we can delete the owner. So to do that, what I'm going to do is we want to, in Solidity, there's no real easy way to delete indexes in arrays. So if you want to delete an index in an array, you can find the index, move it to the last element of the array, and call .pop. So we're going to say wallet owners of owner index is equal to wallet owners of wallet owners dot length -1. So what this does is it gets the index that the owner that we're trying to delete is at, and it moves it to the last index in the array. And then we can just call wallet owners dot pop, and boom, that should be everything. So let's see if I have any typos. I don't. So now that we have that, we can go and test our code. So if we redeploy here, I'm just going to grab this account here, and then we'll add him back in, and then we paste in this owner. Boom, he gets added. If we get wallet owners, you can see we have 2 owners. And let's try and remove this owner now. So we go remove, and boom, if we get wallet owners, we'll see that he gets removed effectively. However, let's try and remove a non-owner. So let's try and go and get this account here, say 0x4b. Go back to the top account. We'll add in this 0xa owner again. So if we get the wallet owners array, we see he's an owner again. However, let's try and delete this other owner that we know isn't a wallet owner. If we go remove, we go wallet owner not detected. So you can see our function is behaving as expected. So the last 2 things that we want to do in this video that I'm going to do is we want to create a deposit and withdrawal function. So in order to create a deposit function in Solidity, we can just type function and call it deposit. And in here, you might think, okay, I'm going to add in a uint amount that we want to deposit. But this we actually don't do this. What we do instead is we go, okay, with this deposit function, we know that we want to deposit ether or send ether into this smart contract. So when that is the case, we actually type the word payable, which lets Solidity know that this is a payable function that can handle the transfer of ether. And then we just want to also restrict this to public. So we'll say public payable, and then we also want to restrict it to only owners. And then what we do is, before we actually deposit money into the address of the owner that's calling the function, we want to make sure that the amount they're sending is greater than 0. So to do that, what we want to do is we want to create what's called a balance mapping. So if we come up here and we declare what's called a mapping. So a mapping is a key value pair. So what this will allow us to do is it will allow us to map a balance to a specific address. So we want to map an address to a uint, and we want to call this mapping balance. And what this will allow us to do, it will allow us to map a balance to all of the wallet owners that our wallet currently supports. So what we're going to do is we're going to come down here, and we want to also make sure that if someone is depositing, then they're depositing in an amount that's greater than 0. So we're going to say require that balance of message.sender, or the balance of the owner that's calling the function, is greater or equal to 0. And then we'll just fire a message that says cannot deposit 0, a value of 0. A value of 0. Boom. And then once we've met that condition, what we can do is we can simply just deposit. So what we'll say is we will say balance of message.sender is equal to another keyword in Solidity called message.value. So you'll notice in here that we didn't pass in an amount, because when we're dealing with ether or depositing ether into a smart contract, the amount of ether that we deposit is stored in this message.value variable. And this message, where we specify this message.value, is not in here, but we specify it in this little box here. So you'll see what I mean in 1 second. So we have that's all we need to do with this function. So we'll save it, and what we'll do is, just before we actually run, we'll write a function to get the current balance of the owners. So we'll say get balance, and this is again is a read-only function. So what we'll do is we'll restrict it to, or we'll have it visibility as public. We'll restrict it to view, and then we will say that this function returns a uint. And when we're returning a number, we don't need to allocate any memory, so we don't need the memory keyword. And then we're just going to say return balance of message.sender, like so. So if I save this now and I delete this instance and I deploy, then we'll be able to, I'm not going to add a wallet owner because we don't need to. So I'm going to deposit in, say 5. I'm just going to change this to ether. And notice how I have 100 ether or 99 ether here. And if I come in now and click on this deposit button, you'll see that this went through. If I get my balance, I have 5 ether, and the balance in Solidity is given in terms of way. So 5 by 10 to the minus, or 5 by 10 to the 18 way is equal to 5 ether. And if I come up here now, you'll notice that this went from 99 ether to 94 ether because I deposited 5 of this account's ether into the smart contract itself. So we can also come in here and we can change into this account and we can choose to deposit, say, 2 ether. And if we do that, then you'll notice if I get the balance, oh, sorry, I forgot to add this this owner. So I need to first of all grab his account and I need to add him in. And then we add wallet owners. That one was successful. And now let's go to this account and try and deposit into ETH. And if we do so, boom, it's successful, and boom, we now have 2 ether. So that balance mapping allows us to keep track of the distribution of funds amongst all of the owners in the wallet. So because this balance mapping here returns the balance of the person who called the function, then if we call it as this account 0xAB, then it will return the balance for him. And if we call it as another account, it'll return the balance specific to that account. So that's that. Now all that we need to do is create the withdrawal function. So to do that, we're going to create a function called withdraw. And the difference is this time, we're actually going to specify an amount that we want to withdraw. And we're also not going to call this function as payable. We're just going to restrict it to public, or have it visibility as public, and restrict it to only owners. And you might be confused here. You might be saying, well, why won't we call this as payable? Because we're dealing with ether transactions. Well, you only call a function payable if that function is sending ether into the contract. Since we're withdrawing, we're not sending ether into the contract, we're transferring ether out of the contract. So we don't need the to use the payable keyword. And when we don't use the payable keyword, then we don't have access to this message.value keyword, so we actually need to specify the amount. So what we need to do here is when we want to withdraw, we actually need to require that our balance is sufficient. We don't want to be able to withdraw more balance than we have. So we're going to say require that balance of message.sender is greater or equal to the amount that we're passing in. And then once we've made this check, we want to update our balance. So we want to say balance of message.sender is minus equal the amount that we want to withdraw. And then lastly, we can actually transfer the funds. So to transfer ether to an address, we need to set that address as payable. So here we use the payable keyword. We need to say payable of message.sender. And here we can call the built-in Ethereum transfer function. So we say .transfer. And then .transfer. And then we can pass in the amount that we want to transfer. And so that's the only difference with the withdraw and deposit function, is we don't actually restrict it to payable, but in order to transfer to an address, we need to make that address payable. And there's one other little security thing I'll go over, is you should always do the security of your function. Then you want to update any variables before actually executing the logic. So this is to do with smart contract security. And pretty much if I was to do this balance mapping below the transfer variable, then perhaps my function could be manipulated where that the amount would always be transferred, and then maybe hackers could figure out a way to end the function before, updating my balance mapping. So it's just always do security, updating of variables, and then the actual logic itself. So now that we have this, our contract code is pretty much finished. I just want to copy this get balance function here, and I'm going to make another function called get contract balance, because there's a difference between the balance of the smart contract and the balance of the users of the contract, and you'll see what I mean now. And in order to return the contract balance, we can just say return address this, which gets the address of the contract, and then we can just call dot balance like so. And oh, I made a little mistake. ADD or ESS. So address this dot balance, and boom. So now what we want to do is we can delete this instance and we can deploy one more time. And here I just do want to add in a new owner. So we get this account here. We go back and we add him in. Paste, and we'll add a wallet owner. And what I want to do now is I want to deposit in 5 Ether. So we can go and click deposit, and if we get our balance, you'll know that we have a balance of 5 Ether. However, if I click on this get contract balance, you'll also know that there's a balance of 5 Ether in the contract, because we are the first person to deposit in. So there's 5 Ether in the contract, and all of that Ether belongs to this address 0x5b. However, if I change to this address 0xAB or 0xAB, and I deposit in, say, 3 Ether. If we click on deposit, you'll notice that went successful, and if I get my balance, we have 3 Ether. So now in the entire contract, there's a balance of 7 Ether. So if I click on this, you can see, or 5 plus 3, there's a balance of 8 Ether, but the balance mapping allows us to figure out what the distribution of Ether is in the contract amongst all of its users. So 3 of that 8 Ether belongs to this account 0xAB, and then 5 of that 8 Ether belongs to this account 0x5b. So I hope that makes sense. The balance mapping acts only as a tool to allow us to figure out the distribution of the entire amount of Ether in the smart contract amongst all of the users of the smart contract. So that is all we're going to do in this video. There's one more thing I want to do, and that is we're going to fire a few events. So events in Solidity are very useful because they allow us to write information or log information to the blockchain really cheaply. And then we can later on in our front end application query them events to get information about certain transactions. So I'm going to make 3 events. I'm going to make an event called wallet owner added. And in here, we're going to pass in an address, and we're going to call it added by. So we want to keep track of the address that added the owner. And then we're going to create an address of owner added. So we want to keep track of owner added. So we want to keep track of what owner is adding and what owner has been added. And then what we're going to say is we're going to keep track of the time that the add a wallet owner function was called at. So we'll say time of transaction. Sorry, I spelled time of transaction. And then I'm going to copy this entire event. And we're just going to come down here and paste it again. I'm going to say wallet owner removed. And then we're going to come in here and we're going to change added by to removed by. And we're going to change from owner added from owner removed. Like so. And then we're going to make 2 more events. We're going to call this one called funds deposited. Like so. And what we're going to do in here is we're going to initialize an address that deposited by. And actually, I'm just going to call this address sender. And then we're going to pass in the amount that was, passed in. And then we're going to also use uint time of transaction. And then I'm going to copy this exact event here. And we're going to paste this here. And instead of saying funds deposited, we're going to say funds withdrawn. And we're going to keep all of the arguments the same. So then what we're going to do is we're going to come down to the add wallet owners function. And here we're just going to emit the event by using the emit keyword. And we're going to pass in the address of the person who called the function, which is message.sender. We're going to pass, we're going to pass the address of the owner that's being added. So we're going to pass in owner. we're going to pass in the time of the transaction, which is just simply block.timestamp, which is a keyword in Solidity that allows us to get the current time of the blockchain. So if we save this now, we have one mistake. Oh yeah, we have to call the actual name. So we'll emit wallet owner added, like so, and that will get rid of that. And then I'm just going to copy this event, and we're going to come down here, and I'm going to emit the event here, and we're going to call this one wallet owner removed, like so. And the owner that was removed was the owner as well, and that's all good. And then in the deposit function, we're going to emit the funds deposited event, and we're going to say deposited by message.sender. The amount we deposited is equal to message.value, and then again block.timestamp, like so. And then the last event, we're just going to copy this, is funds withdrawn. We go into the withdrawal function like this, and we are going to call it funds withdrawn. The person who withdrawing it is message.sender. We only want to change the message.value to be amount. And boom, that is the entirety of the contract that we're going to develop out in this video. So we've set up the user system, and we've gave the users the ability to deposit funds into the contract and withdraw funds from the contract. So I hope you've enjoyed this first part. It probably is going to be a bit long because I gave an introduction, I gave a demo, and I wanted to slow down this introduction because I am taking into account that some of you who have watched or are going to be watching this have never coded in Solidity before. So I really wanted to explain some of these basic concepts that we have been introduced to. In the next video, I'm going to be coding much faster. So yeah, don't be worried. We will be moving at a lot quicker of a pace. So yeah, that's pretty much it for this video. I hope that you've really enjoyed this video, and if you think I've done a good job, then I'd really appreciate if you could just like, subscribe, and hit the bell button to help my channel out with the YouTube algorithm. So yeah, that's pretty much it from me, guys, and I will see you in the next video. We're going to be coding out the transfers system as well as the consensus mechanism to restrict the transfers so that they need to get enough approvals in order to be transferred and all of that. So yeah, thanks for watching, and I will see you next time.